figuring out our normal distributions, and standard deviation stuff. Okay, you guys ever heard of the word skew? Like the data being skewed? It's kind of like, it's like a graph representation of a bias. So we talk about the skew of a graph. Our middle one is obviously our normal distribution. It's got the bell shape. The can't talk and write today, holy. The most of the data is in the middle, whereas if you look to the left and right, most of our data is on the left or the right. Okay. So we say this has a positive skew, and this one has a negative skew. I believe another term they use for positive is like a right tail, so your tail is longer on the right than it is on the left. On the negative, you'd also have the left tail, because that's where the tail is bigger. Skews, like I said, are just a graphical representation of the data. If you have, obviously if you're not normally distributed, you have like a low average on a test, high average on a test, high average of heights, or you also can have outliers. So like something that's pushing your tail way lower, way high. Okay, back to our normal distributions. That's pretty much what we're focusing on. That was just a little vocab. But we have female brown bear weights that are normally distributed. It says the red curve shows how the weights are normally distributed about the mean of 115 kilograms. Okay, first thing we're going to do, when you have a bar chart, I just like to write down the percents of that bar chart. So you see on the left-hand side, it says the percent of our bears, and then each one represents what their weight is. So I like to go through and write down percents so I don't have to keep guessing every time. So like this tail right here, we'll say that's one bear, or 1% of bear, sorry. The next one, we'll call that 5%. Next one is about 23. Then we have about 42. And then just repeated 23, 5, 1. And I believe that should work out to 100%. Okay. Questions on where those numbers came from? Just reading how high the bar is. Okay, so I want to know approximately what percent of female brown bears weigh between 100 and 129 kilograms. Well, that's 100 to 129, these three bars. Okay, we're already given the percent. These are the percents. So all I have to do is add these 3% together. Okay, all I have to do is take 23 plus 42 plus 23. And so what percent weigh between 100 and 129? How about 88? Yes, no, maybe so. Okay, questions there? Okay, the next question says approximately what percent of female brown bears in the above problem weigh less than 120 kilograms? Well, 120 is right here. 120 is included in this 23 bar, but since it says less than 120, we're not going to include the 120. So we're just to the left. Does that make sense? So don't include this bar, just take all of the stuff to the left. Okay? So what percents am I adding together?
43 plus 23.
And how much do I get? 71? Questions there? Okay, this last problem says standard deviation in the weights of female brown bears is about 10 kilograms. Approximately what percent of female brown bears have weights that are within 1.5 standard deviations of the mean? Okay, well, if we go back up to the top in that first paragraph, it says the mean is what? 115. Okay, so we're going to have our x bar 115. And first, let's go one deviation away. My standard deviation is 10, so what's my low number? 105. What's my high number? 125. Okay. Now I need to be within 1.5 standard deviation. So I went 1 away, so now I have to go 0.5 away. Okay. So this time we're only taking 0.5 of our standard deviations. Our deviation's 10, so 0.5 would be 5. So my low number will be 100. My high number will be 130. Okay. Questions with that part? Okay, so we got to figure out what percent are between 100 and 130. Well, 100's here, 130 gets cut off here. So I'm adding what numbers? 23, 42, 23. And what do I get? Say that again. 8. Okay. Questions so far? We have male European eels. The mean body length and one positive and negative standard deviation is shown below. We need to sketch a normal curve showing the eel lengths at 1, 2, and 3 deviations from the mean. So we are going to draw our line diagrams, okay? So in the middle, I have my mean, which is what? 15.7. Okay, the next thing it gives me is what the +1 standard deviation is. Okay, so it says when I add a deviation, I get 18.5. On my low end, I get 12.9. But I need to figure out also 2 and 3 deviations. So I need to find my standard deviation. How can I do that? How do I get normally from my mean to my standard deviation? Or I'm sorry, my next deviation value. I normally add my standard deviation, right? So if I need to figure out what this is, what should I do with these numbers? Subtract them. So what is my standard deviation? It is 2.8. Okay. So my deviation is 2.8. So I have my 1 deviation away. I need my 2. What is my low 2? 10.1. What's my high 2? And then my 3 is, what do I get for those values? Does that make sense? We know how to find standard deviation given this stuff. Okay. we have heights of adult American males that are approximately normally distributed with a mean of 69.5 and a standard deviation of 2.5. So let's draw our diagram. My mean is 69.5 with a deviation of 2.5. What's my low and high numbers? And okay, let's do 3 deviations. Okay, somebody other than Courtney, what are my 3rd deviations? And 77. Okay. We all know how to find those? Okay. Who can tell me what percent of data is all of the numbers less than 69.5? What percent is less than 69.5? 50. Yeah, it's half. 50% lie below. How much lie above? The other 50. Okay. I want to know what percent of adult males are between 67 and 74.5. Well, that's not just a 68 one. I have more than that, right? So let's fill in our percents that we did yesterday. In my middle two, I have my 34%. What's the next value? 13.5. And my outsides are 2.35. Okay, so to find the percent that are between 67 and 74.5, what should I do? Add them. Add what? The percents. So add 34 plus 34 plus 13.5, and we get what? Gotta check that. 81.5. It's okay, Molly. I like the try, especially with mental math. Okay. B says, in a group of 2,000 adult males, about how many would you expect to be taller than 6 feet? Well, first I gotta figure out what 6 feet is. How do I figure out what 6 feet is?
Times 12.
Times 12. What's 6 times 12? 72. So I'm at 72 inches. Okay. So I want to be taller than 72. So from 72 on. Okay. The easiest way to do that is to figure out how much is not in that group. So how much is less than 72? Okay. Well, if I cut it in half, how much is to the left of there? 50 plus this little group, which is how much?
84.
34 for a total of 84, yes. So 84% are shorter than 72. So how do I figure out how much are taller? 100 minus 84. And I get 16. I want to know how many people, because the 16 is a percent. If I have 2,000 people and 16% of them, how do I figure out how many people that is?
Don't you like 2,000 times? No, divide by 60.
First one.
320 people.
Times 2,000 times 16%, and Mike says that is 320 males. Good. Okay. Questions? None. Okay. Last group of problems. Scores on the Algebra 2 final are approximately normally distributed with a mean of 150, standard deviation of 15. Set up your line diagram on your paper, and I'll set mine up here. Okay, check my numbers, make sure we're okay. We good? Okay. It says what percent of the students who took the test scored above 180? Okay, so I need to be above this. Anytime it includes a tail, I would take the opposite and subtract from 100. Does that make sense? So when you're in the middle, like from here to here, you can just add percents. But when you are talking about the tail, I would take your opposite stuff and subtract from 100. Okay? So if I split it down the middle, what percent got less than 150? 50. And then if I add my percents up until 180, 47.5. So if I take 47.5 plus 50, I'm at 97.5%. So is that 97.5% who got above 180? No. It's the ones that got less than. So how do I figure out how many got above? Yeah. 100 minus 97.5, what do I get? So 2.5% of kids got above 180. Okay, you try B. The about should be above. Sorry. So how many scored above 135?
Would we include 135 or no?
Yes. Okay, my 135 is cut off right here, so I want everyone that scored to the right of 135. Well, cut it in half. What's the right hand side that scored better than 150? 50%. And the stuff I have to include now is this chunk right here. Well, what percent is that? 34. So I have 84%. Who stopped there? Hopefully no one. If I have 250 students times by 84%, and I get what?
210.
210 students. Okay. How we feel? Good? Okay, cross out C. Did you do it, Cade?